The density of a material is a measure of how much mass is packed into a given volume, and the particle model of matter provides a clear explanation for why different materials have different densities. According to this model, all matter is made up of tiny particles, such as atoms or molecules, that are in constant motion. The way these particles are arranged and how closely they are packed together determine the density of the material. In solids, the particles are tightly packed in a regular, fixed arrangement. Because the particles are so close together, solids generally have a high density. For example, metals like iron or gold are dense because their particles are closely packed in a solid structure, meaning a small volume contains a lot of mass. In contrast, materials like wood or foam have a lower density because their particles, though still in a solid state, are less tightly packed or contain spaces filled with air. Liquids have particles that are still closely packed, but they are not arranged in a fixed pattern and can move past each other. This means liquids typically have a lower density than solids, although they are still much denser than gases. For example, water is less dense than iron but denser than air. The ability of liquids to flow and take the shape of their container, while maintaining a relatively consistent density, is due to this arrangement of particles. Gases have particles that are far apart and move freely in all directions. Because there is a lot of space between the particles in a gas, gases have a much lower density than solids and liquids. The density of a gas can change significantly depending on the pressure and temperature, as these factors affect how closely the particles can be packed together. Measuring the density of a material involves determining both its mass and volume. The formula for density is straightforward: density equals mass divided by volume. For solids, this can often be done by measuring the mass using a balance and calculating the volume based on the object's dimensions if it has a regular shape. For irregularly shaped solids, the volume can be measured by the displacement of water. When a solid object is submerged in water, it displaces a volume of water equal to its own volume, which can then be used to calculate density. For liquids, density is often measured by placing a known volume of liquid into a container and measuring its mass. Since liquids flow and take the shape of their container, measuring their volume accurately is usually straightforward, which makes calculating density relatively easy. Gases, being much less dense and often invisible, require different techniques for measuring density. The volume of a gas is typically measured by containing it in a fixed volume container, and its mass is often determined by weighing the container before and after it is filled with the gas. The low density of gases can be difficult to measure precisely because even small changes in temperature or pressure can significantly affect the volume. Understanding the density of materials is important in many areas of science and engineering. For example, the concept of buoyancy, or why objects float or sink in a fluid, is directly related to the density of the object compared to the density of the fluid. Similarly, the design of structures and materials often depends on knowing the density to ensure that they can support the required loads without being unnecessarily heavy. The particle model of matter provides a foundational explanation for density by showing how the arrangement and spacing of particles in different states of matter determine how much mass is contained in a given volume. By understanding and measuring density, we can better understand the properties of materials and how they behave in different conditions.